Okay, our fourth lesson in Unit 3 deals with what we call glide reflections. Essentially what a glide reflection is, well, we'll explore that in just a second, but basically it's a reflection along with a translation. And so our job today is to kind of think big picture about all the rigid motions that we've applied, reflections, translations, rotations, and how we can see congruent figures and recognize the rigid motions that took place to get us from the pre-image to the image. And that does require, thinking and some practice by example. And so hopefully we'll be able to visualize what's happening from triangle 1 to triangle 2 or 3 or 4, what has transpired, what has changed with these two-dimensional figures. Here are some fun facts that we have explored, but now we're just kind of putting names to it. We're just kind of naming each of these theorems, each of these statements, and we've seen these at work already. The first is to recognize that every translation is just a composition of reflections over parallel lines. All right, so that work that we've already done in our translations lesson, recognizing that reflecting over a vertical line and then another vertical line has the same result as if we just translate it as many spaces, 2 times the distance between those parallel lines. Lesson 2, any rotation is a composition of reflections across 2 lines that intersect at the center of rotation. We saw this in the very last example in our rotations lesson. Number 3 here, 3.3, the composition of 2 or more rigid motions is a rigid motion. We've seen that at work already, where we did some double reflections or double translations, and it turned out that it just moved the figure. All right, it didn't change its size or shape. And the final one, which is what we're going to explore today, that any rigid motion is either a translation, reflection, rotation, or a glide reflection. Now, when it comes to this glide reflection as a separate concept, it does have a name, right? We're calling it a glide reflection, but essentially a glide reflection is a translation composed with a reflection, or a reflection composed with a translation. We're going to explore if the order of those composed rigid motions actually matters, but we're going to explore glide reflections today in our 4th lesson. So basically, here we go. We just talked about this. A glide reflection is the composition of a translation and a reflection, and we're asking this overall question, does the order of the composition matter? So if we have a translation to the right 4, up or down 0, of the reflection over line M of triangle ABC, does it matter if we switch those? Does it matter if we do the reflection of the translation of triangle ABC? So we'll explore that, but go ahead and have that vocabulary down. Obviously a lot less vocabulary or a lot less content on this because we've already explored translations, we've already explored reflections, and we're just kind of combining those concepts together today. So for our first example, is there a series of rigid motions that will change triangle ABC to triangle A prime, B prime, C prime? And if so, write that composition. So what we're going to recognize here is there's a couple ways to think about this. We can tell that it's not a rotation because the figure doesn't turn upside down as it rotates about the origin or about any other point. What we should be able to tell is that it does look like these are facing opposite directions, and so they are most likely reflected over a vertical line and then translated, all right? It looks like translated down. And so let's imagine what this would look like. How would I get this line to line up over here? That's really what I want. I want for this to reflect so that it lines up with this other one. And so we have to visualize that this is reflecting over this vertical line, all right? Because we want for this intermediate triangle, all right, the one that happens between these iterations of triangle ABC, we want for this to line up with the triangle that we result with, all right? So we want to make sure that we see that. And we can tell that this is reflected over the line x equals -1. Again, the algebra 1 comes in handy there, being able to identify that line. So essentially what we're doing is we are reflecting over this line, and then this point gets moved all the way down there. This one gets moved all the way down there. This one gets moved all the way down here, all right? And so we can tell that it's being moved down 1, 2, 3, 4, 5 spaces, or 1, 2, 3, 4, 5 spaces, 1, 2, 3, 4, 5 spaces. It should all be the same. So I could say that the way that I've drawn this is the translation down 5 of the reflection over x equals -1 of triangle ABC gives us triangle A prime, B prime, C prime. All right. Now, that begs the question, is there another way that we could write that reflection? So when I looked at this, I immediately saw, oh, that they were flipped this direction. I didn't think that it was moved down first. All right, but what if I were to imagine this as the reflection of the translation of triangle ABC? All right, so let's change the order here. Let's do the reflection over x equals -1 of the translation down 5 of triangle ABC. And let's see if it gives us that same result. So let's start by working this the inside out. We're going to translate it down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so that gives me this triangle, which then I can reflect over that same line, all right, to get a distance that's same here, and same there, all right? So this checks out, that our glide reflection can be written in the reverse order when there are these two operations of just translate and reflect. We can simply change that order. Now, if you are going to be doing this over 3 or 4 steps instead of 1 or 2, then maybe that is something that we could explore more. But obviously we want to write our rule in the simplest terms possible. And so reflecting this and translating it, or translating it and reflecting it in the most amounts of spaces possible, is going to be the most efficient transformation. All right, so let's go ahead and try to execute a glide reflection. What we did here is we just did actually the hard part, which was writing the rule for our glide reflection, all right? That we understood that this was a translation of a reflection or a reflection of a translation. Now we're going to do the translation of the reflection of our STV. All right, so we're going to do the translation forward 1 over up 0 of the reflection over the x-axis, y equals 0, of our STV. And that is going to give us, well, let's find out. Well, it's going to give us r prime, s prime, t prime, v prime. And I'm actually going to call these double primes today. And I'll talk about why that is. So first of all, let's go ahead and plot each of these dots to the best of our ability. You're probably already crushing that right now without me telling you to do that. Whoops, I counted to 4 instead of 5. 4, -4. And then 0, -2. All right, let's connect those dots as best we can. All right, this is not a trapezoid, it's just a quadrilateral, nothing special here, no parallel sides, no congruent angles, none of that stuff, no congruent sides. And so we are going to reflect this over the x-axis, over y equals 0. So this again is our line of reflection, this is y equals 0. And so we're going to reflect that so that we have, oh, my red marker. Let me get a new marker. All right, reflecting that over to get t prime. S prime is going to be down here at -5, 0, -5. V is going to be at 0, +2. And r prime is going to be at -3, whoops, -2. There's r prime. And now we're going to connect those dots again to the best of our ability. I know this takes a little bit of time, makes the video a little bit longer. I could do one of those things where it like speeds it up for you. You can press that button too. There actually is a way on YouTube now. I don't think you have to be a YouTube premium subscriber, but I think that you can make this play at like 1.5 times, or 1 2 times, or 1 3/4 times. All right, so there's the reflection over the line y equals 0. And now we're going to translate it forward 1 space. All right, go ahead and try to do that. See if you can do that without me. And it's not too hard. V double prime, T double prime, S double prime, R double prime. All right, so we have moved this figure with a glide reflection. Now, the reason why I am calling these double prime is because we are doing 2 things. And it will make our jobs easier when we're checking our work and discussing with our neighbors if we can see each iteration of this glide reflection. Here we did the reflection and then we did the glide. All right? And we have it graphed and we have it labeled. Now the hope is that you would be able to see, if you only saw the black figure and the blue figure, that you could tell which one, and not which one, but that you could tell what the rule was for the glide reflection. That's the goal. That's fingers crossed the goal. It's the hardest part of this unit, but hopefully we can visualize that and then be able to write that. I would like for you to try this. You get to do this one, example 2B, you get to do on your own. So I'd love for you to give that one a shot. And again, there's no penalty for getting it wrong, but there's penalty for not trying it. You should have 2 figures drawn when you're done here. So pause that and give that a shot, and then come back to the video. All right, so this is, again, the hard part, right? This is the part that is, you know, you can find yourself in one of these 3 dispositions after attempting these items. So our job here is to write a glide reflection that maps JKL to J double prime, K double prime, L double prime. So we're going to try to figure that out. Hopefully you can tell that this has been flipped over, right? That it's been flipped over. So one of the things that I think folks sometimes worry about is making sure that we get it flipped over so that everything lines up perfectly, right? So that this lines up perfectly there, and obviously we have to have it go, whoops, not that direction. Have it go this direction so that we can see where exactly do I need to reflect this. And there's some truth to that. I think that's really helpful to see that this just, if we have it flipped over in the right way, we can just translate it forward. But one of the things that I want for us to understand is, you know, for several folks that have trouble understanding that this is the horizontal line, y equals 1, and writing that equation, it might be easier for us to simply just reflect it over the x-axis, y equals 0. And then translate it diagonally instead of having to translate it just forward. So there are multiple ways in which we can answer this item. All right, there's lots of different ways in which we could write this rule. For example, I could reflect it over the line y equals 1, but then I could translate it forward 1, 2, 3, 4, 5 spaces, and then 0 on the xy. All right, or maybe I want to reflect it over the x-axis, all right, which would again be this picture. Yeah, that's 1, 2, 3. All right, that would be this picture if I reflect it over the x-axis, y equals 0. But then that would mean I'd have to translate it forward 1, 2, 3, 4, 5, and then up 1. Still, I could also reflect it up here, all right, where, let's see, what's the space here? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Or I could reflect it here, about point K, all right? Reflect it over the line y equals 3. But then I'd have to translate it forward 1, 2, 3, 4, 5, down 2. Of the reflection over the line y equals 3. All right, and again, of triangle JKL, you know, to give us triangle J double prime, K double prime, L double prime. So the point is, that I'm trying to show you is, folks, it doesn't matter which of these lines you reflect it over, as long as you're reflecting it over one of these horizontal lines, or any other horizontal line, right? And then translate it accordingly. Now, that's up to me to be able to read that and to tell, okay, they did that correctly, right? I can do that. I can do that grading. Obviously, when you grade a lot of your classwork, if you're having trouble with that, then ask a question and I can get you that full credit. Maybe you want to move it forward first, all right? And so you want the K to line up with the K, so you're going to bring it over this many spaces, and then you can decide how you want to reflect from there. All right, and then if you do it that way, then you are going to have to reflect it perfectly, you know, over really where that line of reflection is, right? Where you can see if this were a figure that wasn't overlapping on itself, where if we kind of envision this as kind of this bow tie looking thing, like if you saw that shape, right, which is kind of those two triangles overlapped, could you tell that there was a line of symmetry in here where it has reflectional symmetry like you would learn about in kind of like elementary art? That's really the intent, and that's the goal here. So if we start to understand where we see that reflectional symmetry, that'll give us a leg up on our next conversation. So again, multiple rules to get the same result, and we want to make sure that we can navigate between those accordingly. All right, I do believe that that's really the end for things. What I'd like for you to do on this last one, example 3, part 2, is I would love for you to try to write the reflection rule that gets us from here to there. Not the reflection rule, like glide reflection that gets us from the black triangle to the orange triangle. All right? And then give yourself, circle one of those smiles. All right? Do we have a happy face, a sideways face, or do we have a sad face after trying that? And then that is kind of the punchline to our glide reflection. So hopefully now you feel comfortable and confident with identifying those rigid motions and writing those rules.